Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra I and II class. Today we are continuing with 11-2, the exponential functions. It was a long lesson, so we're going to get right to it. Real brief, we talked about the fact that exponential functions are in the form of y equals a times b to the x power, where a is the original amount. So for example here, 7 was the original amount. B could be a growth or a decay. If b is greater than 1, then that means I'm adding a percentage to 100%, so that's a growth. If b is greater than 0 but less than 1, it's a fraction or a decimal. That means that you took away a percentage from 1, you subtracted. So that would be a decrease or a decay, all right? So we had said for these two, let's just make sure we do it the right way. Determine if the given exponential functions are growth or decay. Find both the growth or decay factors and the rate or rate of growth or decay. All right, so for this particular case, that is going to be growth or decay? Decay. Okay, now, the decay factor is 0.85. But what was the rate of decay? Very good. The rate of decay, if you go 1 minus that, it's going to be 15%. Very good. Decay. Excellent. Yes, sir. The 7 is just the original amount. That does not determine whether it's growth or decay, sir. For number 2, 3.2, what is the, is that growth or decay? That is growth. The decay factor is itself 3.2, but what is the rate of, it's not decay factor. Come on, Mr. Morrow, thank you. Growth factor. What is the rate of growth, though? The rate of growth, you subtract that from 1, and that would be 2.2. Very good. Okay, awesome. Awesome. Now, you contribute $2,500 into a college savings account for 3 years, and the account pays 7% annually. Would that be a growth or decay? It would be a growth. Okay. What would my decay growth factor be? Now my growth factor, it'd be 1 plus the rate of growth, correct? So plus 0.07, so it'd be 1.07. What is my rate of growth? My rate of growth, my rate of G, would be the 7% or 0.07. So you add the rate of growth to 1, you subtract the rate of decay from 1. Does that make sense, my brothers? So if you wanted to find out an actual value for this, an equation, this would be y equals, you start with $2,500 times 1.07 to the x power, because your money is growing at 7% every year, and you're starting with that much amount. It's not that bad, is it? And you're making a really complicated equation here, and it's not that bad. Really proud of you. We got to move on, guys. I know I'm going kind of fast, but we got to move on. Okay, what about this? My cousin invested $3,000 into a savings account at the end of 8th grade. The account pays 8% annual interest. How much will be in the account after 4 years when he is ready for college? Well, y equals my original amount of $3,000 times, this is paying you an amount. It's paying. So it's going to be an increase. So it's going to be 1.08. It's going to be a growth to the x power, where x is the number of years. And that's going to be 4. Yes, it is. Now, in this particular case, of course, you are going to be allowed to use a calculator. What the calculator cannot do for you, and I will repeat this a million times, it cannot create the equation for you. So if you think, oh, Mr. Morrow is being soft with us, no, I am not. The calculator cannot create the equation. So if you have the wrong equation, it doesn't matter what calculator you have, it's going to be wrong. And be careful when you're doing this. 3,000 times parentheses 1.08 close parentheses raised to the 4th power. Make sure you follow the order of operations. So you're going to have $4,081.47. That will be how much money you will have in 4 years. So as you can see, you better save a lot of money. Okay? Does that make sense so far? Did everyone get that on their calculator? I see some people working on their calculator. Okay, good. If you didn't, you may have messed up with your calculator keys. So just be careful, please. Okay. How much money will I have after 5 years if I deposit $1,500 into a savings account paying 2.75% annual interest? Well, my Y is going to equal my original amount A, which is $1,500, times, remember, 2.75% is 1 to the left, 0.0275. That's what you add to 1 because this is a growth. So this is 1.0275 to the x power, which equals the number of years. So that's to the 5th power. And go ahead and you can see how I would not mind you using calculator. You can do this by hand. Absolutely you can. But you don't have to. So this would be, you should have had $1,717.91. Yes, sir. Okay, how did I get the B? Thank you for asking. Isn't the account paying you 2.75%? So isn't that a growth? So growth, it's 1 plus my rate. So in this case, it was 100% plus 0.0275. Are you sure? You promise? Okay. Anyone else having any issues at all with this? May I continue? You sure, guys? Yeah. Okay, thank you. All right. Got an endangered species here. The table shows the world population of the Iberian lynx. It's one of the most beautiful and rare lynxes on Earth. In 2003 and in 2004, they had some population numbers. If this trend continues and the population is decreasing exponentially, how many Iberian lynxes will there be in 2014? Okay, all we were given is the original amount in 2003 and the new amount in 2004. So my original amount, my A, is 150. Now, how do I find the percent change here? Remember the percent change formula, my friends. Percent change equals new minus old divided by old times 100. It's a percent. So my new value is 120 minus 150 over 150, which gives me negative 30 over 150. So that gives me negative 1/5. So that's a 20% decrease. But Mr. Morrow, it's negative. There are no negative percents. It's either up or down. So when you have a negative percent, that means that it's a decrease. So what is my exponential function? Y equals 150 times 0.8 to the x power. Why 0.8, Mr. Morrow? Because we have a decrease. So when we have a decrease, my growth rate, or my in this case, my decay rate, or a factor rather, is 1 minus 0.2, which is 0.8 of the original. You're going down. This is a decay. And now, I want to know how many lynxes will be left in 2014. So from 2013 to 2014, that's 11 years, right? So 150 times 0.8 to the 11th power. So I got 150 times parentheses 0.8 raised to the 11th power. And unfortunately, that is a sad number. There are probably about, it's 12.9, roughly about 13 left in the wild. And that's sad. You're losing 20% every year, guys. Numbers add up. Does that make sense? This is how people find out, not people, scientists, biologists, zoologists, people that work with Greenpeace, endangered species. The math tells them what the future holds. Okay? Does that make sense, though, my friends? Setting up the equations, pretty good? Okay, let us continue. Now, a variation of exponential is compound interest. It is the same thing, except they're adding a few little tweaks to it. Compound interest, first of all, is an account that pays interest on your balance. Let me explain what I mean by that. If I pay you simple interest, let's say that you put in $100 into a bank, and I pay you 10% simple interest. After year one, okay, I'm going to pay you $10, right? So your balance will be $110. But in year two, I'm still going to pay you $10. And then year three, I'm still going to pay you $10. Simple interest pays only on the original amount. Okay? Compound interest. Compound is a little bit different. Compound is a lot more dynamic. It's a lot more lucrative. Year one, you're still going to get paid $10, right? But now year two, compound interest pays on the balance. Now you're getting 10% of $11 of $110. So year two, you'll have $11, right? Now your new balance is $121. So year three, you're going to get $12.10, etc., etc., etc. Compound, think of the word compound, it takes what you started with, takes your interest, it adds it together into what's called the balance, and it pays you on the total balance. Again, what is balance? Balance is your original amount plus your interest. That's your total balance in an account. So, what is the function? Y equals A, where A is still the initial amount. Nothing really changes. And now, since it's a compound interest, it's always adding. So it's 1. We know that because that's how we get our B, right? 1 plus R or 1 minus R. But in this case, it's 1 plus R over N to the xn. N is the new thing that we got to worry about here. Not really worry, but focus on. R is the interest rate. We know that it's a percent. N is the number of payments, guys. Compound accounts can pay annually, where N is 1. Quarterly, that means that it pays 4 times a year. Monthly, pays 12 times a year. Daily, pays 365 times a year. Semi-annually, N pays 2 times a year. And X is time in years. So it's A times 1 plus the rate over the number of payments times the number of payments to the X number of years. It looks complicated, but it's actually not at all. How much will you have in an account that pays 7% compounded semi-annually interest if you invest $3,000 after 4 years? Y equals A, my original amount, times 1 plus R, my R is 7%, so 0.07, divided by N, the number of payments, semi-annually, 2, to the X number of years, times N number of payments. Literally, that's it. Be careful inside of here when you're doing this in your calculator. Be careful. If I were you, I would first calculate what that was. So 0.07 divided by 2 is going to be 0.035. So this is 3,000 times 1.035 to the 8th power. So let's go ahead and see if we got our math right. 3,000 times parentheses 1.035 parentheses to the 8th power. And that should equal $3,950.43. Does that make sense, my friends? And are you getting that value? Wasn't that bad, was it? Pretty easy. Okay, let's do another one, please. John invests $6,000 into an account that pays 12% interest compounded monthly for 3 years. Find the balance of this account. So y equals A, my original amount, times 1 plus r, my interest, which is 0.12, over n, the number of payments, which in this case is 12, to the 3 times 12 power. I suggest you calculate this inside here first. 0.12 divided by 12 is 0.01. So this is 6,000 times 1.01 to the 36th power. So 6,000 times parentheses 1.01, close parentheses, raised to the 36th power. And you should have $6,584.61. Does that make sense, folks? Promise you were good? Okay. Now, told you this is a long lesson. Last thing, guys. When we're dealing with exponents, okay, and exponential equations, there's an extremely important property you must remember. When you have a to the x equals a to the y, and your bases are the same, you can literally drop the bases and the exponents will be equal to each other. So if I have 2 to the x equals 2 to the 7th, I can literally drop the bases and make this x equals 7, and I'm done. That is a true exponential property. It is an exponential property. When you have a base, raised to whatever power, equals that same base raised to whatever other power, you can drop the bases and the exponents will become equal to themselves. The goal when solving exponential equations is to find and convert common bases using the properties of exponents. So let me explain what the heck I'm talking about. I have a base of 2 and I have a base of 32. But if I think about it, 2, 4, 8, 16, 32. Can't I turn 32 into 2 to the power of 5? Now the bases of 2 cancel. X minus 3 equals 5. Add 3 to both sides. X equals 8. And guys, I hope you realize you are solving some complicated stuff. But as long as you remember the power of this property, and you know your times tables, and you know how to convert, you're going to be fine. For B, base of 4 and base of 32. Okay, 4 to nothing is going to equal 32. However, 2 squared, right? So 2 squared is the 4. You still got to raise that to the x squared. Equals 2 again to the 5th power. The bases cancel. What happens when you multiply, when you raise a power to a power? So that's going to be 2x squared equals 5. Divide by 2. X squared equals 5 halves. Square root both sides. X equals plus or minus square root of 5 over square root of 2. I got to rationalize square root of 2 over square root of 2. So x equals plus or minus square root of 10 over 2. It's putting all of our skills to work here. All of our skills. But it's easy if you remember how to break down bases and if you remember your exponent power rules. Okay, here. This looks complicated, but it's not. What happens when you subtract the same bases? I messed up. When you divide the same bases, subtract the exponent. So wouldn't this really be e to the x squared minus 2x equals e to the 8th? Do you see that, guys? The e bases cancel. So I got x squared minus 2x equals 8. So I got x squared minus 2x minus 8 equals 0. So now I factor. Again, these are skills we know. Negative 4, positive 2. So x will equal 4 and negative 2. Bingo. We got it. Does that make sense? You promise? You guys are awesome. Thank you very much. Have a great day. Hope you learned a lot. Homework is valid. Be good.